Okay, so now we move to Fourier series. Okay. Okay, these are the syllabus for Fourier series. I hope that we can finish up until effect of Fourier series characteristic for today. Okay, so Fourier series, basically the syllabus is not that much, so we can finish it within 2 weeks time. Actually, we can finish it in 1 week, but include all the examples and tutorials. I think it's better to make it in 2 weeks. Okay, and then okay, sinusoid signal, it means the sine and also cosine signal. Okay, so we are going to learn how to express the signal in mathematical representation. How to plot the signals in terms of time domain. We have many types of representation for this signal. Okay, we can plot in terms of time domain, and then we can plot in the frequency domain spectrum. Okay, so remember a signal we have time domain and we also have frequency domain spectrum. Okay, and then I'm going to show you how to represent the signal, the same sinusoid signal in terms of exponential or phasor representation, and in terms of complex exponential representation and also periodic signal. And if you notice also at the first part of the e-learning, I put all the general information as well as past question paper, formulas, and also all the notes that are relevant for all chapters. For example, I put a revision on complex numbers. So I hope you can study that, okay, because it is crucial for you to recall back your memory on the knowledge on complex number, on how to change between rectangular number, okay, to polar number and vice versa. Okay, kalau you still ingat mathematics, change rectangular number, complex number into polar number yang ada sudut tu, okay, with the degrees. And also how to represent the complex number on the graph. Okay, so please also download and study that. Okay, so first for the sinusoid signal, we can express the signal, okay, in terms of time domain. It is actually a common type of signal used in communication system. Okay, sinusoidal signal. Okay, it means that cosine and sine signal. So for example, here is a EMT wave, periodic vibrations of musical instruments, and also acoustic wave. So this is the equation for the time varying voltage signal. Vt is equal to A naught cos omega naught t plus theta naught. So this is an example of sinusoidal signal. How we represent it in terms of time domain mathematical representation. A naught here refers to the amplitude of the sinusoid. Okay, and omega naught here is angular frequency. So recall back, omega naught is equal to 2 pi f naught. Okay, 2 pi f naught. And theta naught is the phase shift. Okay, whether the signal shift to the right or to the left. Okay, so this indicates the shift, the theta naught. It also can be written as sine omega naught t plus theta naught, but with a difference of pi over 2. It means that if you want to represent cosine here into a sine signal, you can do it, but you have to put the difference of pi over 2. Okay, you have to also look at the trigonometry series. For this, you don't have to memorize, but you have to refer back to the list of formulas. Okay, list of formulas that I also have uploaded on the e-learning. Actually, list of formulas will be given in the exam. Okay, so you just need to know how to use that. And also, this trigonometry series is part of that formula. Okay, list of formula. Sinusoid signal can be represented in time domain and also frequency domain, like I said before. Okay, so if you want to represent cosine to sine, okay, so what you have to do is you just represent it in plus shift pi over 2. Okay, so instead of theta only, you add pi over 2. Okay, so for time domain, Okay, this is time domain graph. Let's consider that this is a time varying voltage signal. Okay, not only voltage, you can plot in terms of current. Okay, current also, or any other values of the amplitude. So for plotting this time domain, remember to put V in the bracket T. It means that this is a time domain signal. This is a function of voltage that vary with time. Okay, so T here is equal to 1 over F naught. Okay, T is the duration. This is T, one duration of the signal before it repeats again. It's also equal to 2 pi divided by omega naught. So how to get this? Remember that omega naught is 2 pi F. Okay, so you rearrange back the equation, you will get this. Okay, and A naught here is the V peak here. Okay, A naught means the V peak here, which is the amplitude of the sinusoid. Omega naught is the angular frequency. We call it angular frequency, which is equal to 2 pi F naught. Theta naught is a phase shift. Okay, it means that if the signal is shifted to the right or to the left, this is a theta naught. Okay, the shift. Okay, and T is the duration of the signal before it repeats itself. Okay. Okay, for frequency domain, each sinusoid signal has frequency, amplitude, and phase. Okay, just now we have looked into the time domain. Kalau frequency domain, we plot against frequency. Okay, we plot the signal against frequency instead of time. Okay. So it has amplitude, it has phase, and it also have frequency. Amplitude and phase can be plotted with frequency to produce spectrum signal. Okay, let's say we have this equation in terms of time domain. How are we going to plot this equation in terms of frequency domain? First, we notice the amplitude. So here we have two amplitudes, A1 and also A2. So in order to plot frequency domain, we have to plot two graphs. Okay, when the question asks you to plot in terms of frequency domain, you remember that you need to plot two graphs. The first one is amplitude spectrum. The second one is phase spectrum. Okay, unless the question asks you to plot only amplitude or magnitude spectrum. Okay, we can also call this magnitude spectrum. Then you plot only one. But if the question asks you to plot in frequency domain, then you need to plot two, amplitude and phase. So for the amplitude spectrum, we plot against omega, okay, or frequency. So we know that 2 pi f1 is equivalent to omega 1. So at omega 1, we plot A1. So omega 1, we plot A1. Okay. And at omega 2, we plot A2. So how are we going to know the amplitude A1 and A2 here? This is only the example. So I assume here that A1 is higher than A2. The magnitude is bigger than A2. So I plot A1 higher than A2. 2 is 2, then you plot like this. But if A1 is 2, you plot shorter than A2. Okay? And A2 is 3, for example, you plot A1 shorter than A2. Okay, and then another one, you draw phase spectrum. So this is against omega as well, because this is frequency domain. You plot here in terms of the phase shift. Okay, so this is theta 1. So let's see theta 1 here is given less than pi, so you plot like this. Okay, and theta 2 here is negative, so you plot at negative side. Okay, so any question regarding the frequency domain? Ada soalan? Clear? Clear everyone? Hello? Is it clear? Alright. Okay. So, okay, let us see exercise 1. Plot the amplitude spectrum and phase spectrum for signal below. So, it is given this signal. Okay, again, I assume that we don't know the value of A, B, C. So, you just plot the magnitude. Okay, whether it's high or low, you just assume. So, this is an example only. So, given A cos omega naught T minus B cos 2 omega naught T plus C sine 3 omega naught T. Actually, if you want to plot amplitude, you can plot B in terms of negative. Okay, but if you want to plot magnitude, you have to plot in terms of positive. And also, you can change negative cosine here to positive cosine by using trigonometry series. Again, this is all in the formula, list of formula. Okay, so in the list of formula, negative cosine theta is equal to cos theta plus pi. So you change this part, okay, to positive, you put plus b cos 2 omega naught t plus pi. Okay, and in order to plot this, you have to make sure that all have the same omega, omega naught, and omega naught, right? And then you change the sine part, okay? You cannot plot this if you don't change it to cosine. You have to change to cosine first. So it's either you change all to sine or you change all to cosine. Okay, that's the rule. Okay, so you plot in terms of cosine. So you use the we call this the trigonometry series. So sine theta is equal to cos theta minus pi over 2. Okay, so you plot A, B, C, omega naught, 2 omega naught, and 3 omega naught, and the theta here. Okay, theta here. Some of the books also use phi. Okay, you can use either symbol because it represents the sudut, okay, the degree or the phase. Okay, so for omega naught, there is no phase. Okay, so there is no plot here. For 2 omega naught, there is a phase shift by pi. And for 3 omega naught, there is a phase shift by negative pi over 2. Okay, so this is how you plot amplitude spectrum and also phase spectrum. Okay, boleh Okay, and then okay, now I'm going to show you some examples on how to plot sine and also cos function, cosine function. For the first one, okay, sine t and t subset of 0 and 2 pi. Okay, so we know that this is actually sine omega t. Okay, if you mesh with the original equation. So from here, you know that omega is 1. Okay, because there is no number next to t, right? So omega is also equal to 2 pi f naught, which is also equal to 2 pi over t naught. Why I obtain like this? Because f naught is equal to 1 over t naught. So from here, if you rearrange, the most important thing is you need to get this number, t naught. Because when you want to plot, you need to know what is the duration of one whole cycle of the signal. So t naught is equal to 2 pi. Okay? So you kena dapatkan t naught ni because you kena tahu apa values of satu cycle, okay, for the sine. Okay, so once you got t naught, then you can draw. Okay, and remember also, given here t is subset 0 to 2 pi, means that you just need to draw the signal between this time. Okay, so this is a sine signal. So remember, for the sine signal, it starts from 0. Okay, starts from 0. This is a sine t. This is, or you can put y equal to sine t. This is t. Okay, so t naught is 2 pi. So the whole duration here is 2 pi. Okay, this is how you know what is the duration of the signal. And this is pi. Okay, and you cannot draw further than this 2 pi because it is given that t is just from 0 to 2 pi. Okay, so the same goes for y equal to cos t. You will get here omega equal to 1 equal to 2 pi over t naught. So t naught is equal to 2 pi. So for cosine, okay, you know the cosine starts from here, right? Okay, so it will go like this. Hilang. Okay. So this is t. This is 2 pi because t naught also 2 pi. So this is 0. Okay. The highest here is 1. This one is also 1 because the amplitude of sine t here is 1. Okay. Bila sine t ni maksudnya this is 1 sine t lah. Alright. So in the middle here is pi. Alright? Okay. So when say plotting, we just need to plot the whole duration. Okay, if you put the T naught here, so we know that this is correct. Your plotting is correct. Okay. Janji you kena label the whole T naught ni. Okay, the duration here. Okay, so that is the basic of plotting. Label. Okay, you draw the whole cycle and make sure at least you label one of the at the x-axis and also y-axis ni you label. Mesti ada satu label here, which is here 1, okay, the amplitude, and here is the whole duration. Okay, ada soalan lagi? Clear for this page? Jangan malu Alright. Okay, if you need to ask question, don't hesitate to turn on your apa nama tu microphone and ask. Okay, second question, plotting sine and cos function. Okay, this one is cos 4t. Okay, for y equal to cos 4t, the question didn't put t subset to 0 or to pi. Okay, it means that this is a continuous signal. Okay, so again here, the amplitude here is 1. The omega here is 4. Okay, so from here you can get the T naught. So T naught here is berapa? 2 pi over 4. Okay, which is pi over 2. So maksudnya the whole duration is pi over 2. Okay, so you know that for cosine is something like this. Okay, but because there is no apa nama limit for the time, there's no limit for time, so it can start from daripada belakang lagi lah, right? So this is y. So for the whole duration here, this is from 0. This one here should be pi over 2. Okay, before it repeats again. Okay, so this is y equal to cos 4 over t. So it means that the half of the wave here should be pi over 4. Okay, this one you tak label pun tak apa, as long as you label the whole duration. Okay, this is the T naught. Okay, alright, another one is y equal to sin t plus sin t divided by pi. So this one given that t is between -1 to 2. Okay, so here if you take out omega is actually 1 over pi. Okay, which is equal to 2 pi over t naught. So t naught here, you rearrange, you will get 2 pi over pi, which is 2. Okay, so now you can plot sine. Sine starts from here. Okay, because the question say this is from -1 to 2, so you can put here 2 because t naught here is 2. So here is 1, right? And because it is from -1, so this is -1. Okay, so this is the amplitude here is 1 also. Okay. Alright, so any question regarding the plotting sine and cosine function? Boleh ke? Hello? I need to hear your feedback.
Boleh, madam, boleh.
Okay, thank you, Amirul.
Doctor, for the
Okay.
T naught, should be 2 pi squared, right?
Which one? This one? T naught?
2 pi squared,
Sekejap,
not 2 pi per pi.
2 pi squared. Pi squared ke? Kejap, omega naught equal to 1 over pi. T naught equal to 2 pi squared. Sekejap 2 pi divided by 1 over pi. Oh, 2 pi squared Oh, okay. So saya salah kat sini lah. So this one should put 2 pi squared. Kalau macam tu, if in this is the case, okay, you know what is the value of pi, right? So you try to calculate pi squared multiply by 2. Okay. So you get that value. Berapa Cuba calculate sekejap. So pi squared divided by 2. Dapat tak? Ada siapa dapat? Yeah, I got 19 something. So it means that katalah that is the case. Okay, so maybe I ada mistake kat sini to calculate this. So this one should be 2 pi squared. Okay, so this one I got something around 19.7 now. 19.7. So if you divide by 2, okay, you will get something here is 9.85. Okay, so it means that your signal have to cut short to somewhere here. Okay, at 2. Okay, means that when you draw, should be sikit je. Okay, you should draw up until here only. This sign kan. Okay ke? Dia sepatutnya something like this. Okay, ni tak payah. So like here. Kalau if t is between -1, unless if there is no this value, then you can draw something like this. Okay? Hello?
Madam,
Yeah?
so the full oscillation is still until 2 pi square,
Betul.
but we
It's
draw
like,
it until 2.
you depends on this.
Okay,
Okay?
domain.
So I think I have to check back. Okay, sama ada I betul ke salin this question correct. But if this is the case, you tengok balik dekat this. Okay, T. Okay, if there is no condition, then you plot the whole cycle. Okay? Hello? Any
Okay, Doctor.
okay. Alright. Kejap Okay. So let's move on to
Hello.
yes.
Yeah, ma'am. If there is not given any condition, what would be there?
You just draw the whole cycle like this.
Okay.
You just
Just
draw
on.
the whole cycle. Just
Okay.
draw the whole cycle. Yes.
Okay. Okay. Take it.
All right. Okay. Thank you just now. Siapa yang I nampak May something. May apa your name? Okay. Thank you for pointing out my mistake. All right. Okay. Oh, there's another one. Okay. There's another one here. Okay. I think for this one, you can try to do it by yourself. Okay. For this one, we have ini actually this question I spelling wrong. This is cos -40. Negative it should be inside here. Okay. Cos -40. Another one is y sin t plus pi over 4. Okay. So you can try to plot this. For this one, cos -40, you can change first to using trigonometry series. Okay, you can change first and then find out the t naught. Okay, and for this one, sine t plus pi over 4. For this one, omega here, is equal to when you plot sine t just now. So for sine t just now, you get omega equal to 1. So t naught is equal to 2 pi. But for here, for this question, you have shift by pi over 4. Okay, so pi over 4, you shift, this is plus. Okay, so you shift to the left. You shift ke kiri, you shift ke kiri. So instead of start from 0, kalau you plot sine kan it starts from 0. So at t equal to 0, so you start at t equal to negative pi over 4. Okay, so you cuba try dululah. Alright, boleh try to plot it. Dah salin ke? Have you copied this? Because this will not be in the slides, okay? Okay, and then we move on to another representation, which is the exponential representation. Okay, for this exponential, you project the signal in terms of x-axis and y-axis using anti-clockwise rotational phaser. Okay, it means here for x-axis, it indicates the real number. The y-axis here, it indicates the imaginary number. Okay, kalau you ingat, we have a complex number, we have real and also imaginary. Okay, for equation Vt equal to A naught cos omega t plus theta naught, this A naught is actually the magnitude of this, or the length of this line here. Okay, line here, A naught. So kalau A naught too short, we should plot shorter here. Okay, and omega t plus theta naught here is the phase. Okay, the phase on this graph here. Okay, this one, you need to do the revision of complex number on the graph. I already put or upload the notes okay, on the e-learning. So please have a look. So here, when there is no theta naught here, okay, when theta naught here is 0, it means that there is no shift here. Okay, so only real number involved. Kalau lah theta naught is 0, there is no theta naught, and it is only A naught cos omega t, so this is A naught. Okay, so no imaginary number. Okay, and then this is exponential representation. We can also represent the signal in terms of complex exponential representation. Okay, this is very useful to analyze the signal. So let us see again how to the same signal, how to plot in terms of complex exponential. We have Vt equal to A naught cos omega t plus theta. So we use Euler's theorem. Okay, this is a Euler's theorem. Okay, this is also in the list of formula. Okay, but it's easier for you if you memorize this because we are going to use a lot, okay, of Euler's theorem in the next calculation. So Euler's theorem said that cos theta is equal to exponent j theta plus exponent negative j theta divided by 2. Okay, this is for sine, cos. For sine, I think, I hope this is correct. This is exponent j theta minus exponent negative j theta divided by 2j. Okay, this is for sine. Okay, for sine, it has this imaginary number. Okay, so to change Vt here, you put cos omega t plus theta here, you put in the equation A j theta. Okay, so for cos theta here, instead of just theta, you put here omega t plus theta. So the equation becomes A naught over 2 exponent j. J tu keluar dalam kurungan, is outside the bracket. Okay, and then inside the bracket you put omega t plus theta plus exponent negative j, and then inside the bracket omega t plus theta as well. Okay, must be the same. Okay, omega t plus theta must be the same inside the bracket. Okay, and then to plot here, we have A naught over 2, okay, positive side, okay, A naught over 2 negative side because of this phase. Okay, So the first phase is omega t plus theta. The second phase is negative omega t plus theta sebab kita dah pecahkan dua. Okay. This is in terms of exponential representation. Boleh Anyone? Okay. So in the complex graph, okay, if you refer to the notes that I have uploaded, okay, we have coordinate. Okay, we have this is a real number. Okay, this is the imaginary number. Okay, coordinate here 1 0, negative 1 0, negative 1 1, 1 1. Okay, negative 1 0 means only real number. There is no phase. Okay, for negative 1 1 here, you have pi over 2. Okay, pi over 2, it means the phase. Okay, but there is no real number. Okay, this one is negative pi over 2. This is negative pi. Okay, so nanti you tengok bila you see this j, it also means pi over 2. Okay, so it is important for you to understand this. Then you can do many more Fourier series. You can solve many more Fourier series equation. Okay. Just now we already learned how to plot in terms of single-sided spectrum. Okay, remember that tadi kita dah buat kan? Kita plot, just now we only plot the spectrum or the frequency spectrum from this equation. Okay, just from this equation you plot. Okay, so if you plot straight from sine or cosine equation, then you plot in terms of single-sided. Okay, it means that you plot only one side, not both sides. But if the question asks you to plot in double-sided spectrum, it means that you need to change the signal here, the cosine or sine equation here, into complex representation. Okay, so this signal can be seen as one function which is generated by two complex components. Okay, because when you change cosine here into the complex equation, it will have two part. Okay, two part of components. Okay, first a0 over 2 exponent j omega t plus theta. Another one is a0 over 2 exponent negative j omega t plus theta. So this signal can be plotted in amplitude and phase spectrum as below. Okay, again we have two graphs, which is amplitude and also phase. So both graphs are plotted against frequency. So the first graph here, you plot negative and positive side of frequency because we have omega and we have negative omega. So here becomes a0 over 2. Here also a0 over 2. For the phase, at omega you plot theta, at negative omega you plot negative theta. Okay, kalau you open up this bracket, you will get negative theta. Okay, so this is double-sided spectrum. If you compare back with the single-sided spectrum, kalau I buka balik single-sided, single-sided, okay, this is a single-sided, only right side, okay, only one side of the plot, okay, and this is the full amplitude. For example, this is A1, this is A2, the full amplitude, okay. But if you plot against the frequency for double-sided spectrum, the amplitude will divide by half. It will become a0 over 2 and a0 over 2. Okay, so this is important. It's also important for you to take note of the question, whether the question asks you to plot single-sided or double-sided. Okay, so again, kalau you want to plot, if you want to plot single-sided, you just need to change all the equation into cosine or sine. Okay, you can choose whether cosine or sine. Okay, but please plot into cosine. Maksudnya please change into cosine, so that is easier for us to mark. Okay, it's easier also. Okay, because normally when you plot into sine, then you want to plot the complex number, it will involve j, which is a imaginary number. Okay, now when the question asks you to plot double-sided spectrum, you use this equation, the Euler's theorem. Okay, to change from a naught cosine omega t plus theta into these complex numbers, and then you plot negative and also positive side. Okay, ada soalan tak? Is there any question? Ada soalan?
Oh, madam.
No. You want to have a break now, or we can proceed? Please let me know. You okay to proceed? Okay to proceed, or you want to have a break? 5 minutes break?
5-minute break.
Ada. Okay. So, okay, we break for 5 minutes. Okay. Okay. So, now we recall back our knowledge on harmonic signal. In other words, it is harmonic signal. It is an infinite series of sine and also cosine functions of the harmonics of the fundamental frequency of the signal. Banyak off dah. Each term having an amplitude coefficient multiplier. Okay, it means that for this harmonic signal, we have one fundamental frequency. Fundamental means the smallest frequency for that signal. Okay, so it have and for the another frequency we have amplitude coefficient multiplier. Okay, based on that fundamental. For example, F naught berulang balik bila interval T naught. Okay, this is the example. It can be in terms of sine, square, triangle, as long as it repeated itself. Okay, the equation for periodic signal is this: Vt equal to Vt plus minus nt naught. Okay, n should be integer, nt naught is 1 over f naught. Okay, now we go to Fourier series. Fourier series can be represented in terms of Fourier series trigonometry or complex exponential Fourier series form. So remember that this is two forms of Fourier series. Okay, so the question can ask you to represent Fourier series either in the trigonometry or in the complex exponential Fourier series. Okay, so what is Fourier series? It is actually a representation of complicated periodic signal in the frequency domain by its frequency components or spectrum. Okay, example here is the representation of musical sounds as sums of waves of various frequencies. Okay, it means that if you have a periodic signal, okay, the summation of many periodic signal with one fundamental frequency, and how you're going to represent it, that signal. Okay, so we present that periodic signal in terms of Fourier series. Okay, that is Fourier series. You represent the complicated periodic signal. Okay, you can represent it in terms of frequency domain by its frequency components. Okay, basically it's a mathematical representation for periodic signal. Okay, so the first form here is Fourier Series Trigonometri. Okay, we represent this Fourier series in terms of trigonometry, which can be written as infinite cosine and sine function. Okay, it is infinite because it is periodic and harmonic and it is forever. This is general form of Fourier series. Okay, first Vt is equal to a naught over 2. So the first part here does not have any cosine or sine wave component. And then A1 cos omega naught t plus A2 cos omega naught t blah 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 up until an cos n omega naught t. And then plus the sine component. Okay, B1 sine omega naught t, B2 sine 2 omega naught t up until Bn sine n omega naught t. So you notice that when we write the Fourier series trigonometry form, we start from the component that does not have any cosine or sine component. Okay, sine wave. And then we start with the smallest fundamental frequency, which is omega naught. Okay, and go on to cos to omega naught up until the highest and omega naught. And then only we write the sine part. Okay, with the smallest fundamental frequency and then 2 omega naught. So this is how you arrange the Fourier series trigonometry equation. Okay, or to make this equation further simpler, we can represent in terms of a naught over 2 plus the summation from n equal to 1 up until infinity. an cos n omega naught t plus bn sin n omega naught t. Okay, this is how you simplify the above equation. Okay, and a naught here, hello, ada soalan ke? Okay, a naught here is DC component. Okay, it is a DC component. Um, an and bn here is Fourier coefficient. Omega naught here is fundamental frequency, and omega naught is referred to harmonic frequencies, and n can be 1, 2, 3, 4 up until infinity. Okay, so part yang tak ada, the part that has no cos or sine wave, it is what we call DC component. Okay, it determines whether your signal here is shifted in terms of shifted up or down. Okay, DC component. Maksudnya dia akan because this is a DC component. Let's say this is 1. It means that the whole signal is shifted by 1 to the up the x-axis. Okay, ke atas. Okay, to plot the frequency spectrum, Fourier series should be represented by this equation. Vt, okay, yang tadi kita tengok equation, we can further simplify it in terms of this. A naught over 2 plus summation of 1 until infinity, an cos n omega naught t plus theta n. Okay, so just now we have an and bn part. Okay, remember we have if we refer to the previous equation, we have an small a here plus bn, okay, small b here. So we can further simplify the equation to become this. Okay, so an here, the capital A here is, okay, the square root of an squared plus bn squared, which is the cosine part plus the sine part components. And theta here is arctangent, ARC, arctangent, negative bn divided by an. Okay, so yang itulah. Okay, this is theta n. And Fourier coefficient an here and bn here can be obtained by integration of the original Vt. Okay, so a naught is equal to 2 divided by t, integration from 0 to t Vt dt. Okay, and an you integrate at the cosine part, bn integrate at sine part. Okay, again, if you have the list of formula with you, you can check whether this is included in the list of formula. If I'm not mistaken, it is included. Okay, and so far I've never seen an equation for the latest equation lah. Okay, we're talking about from 2012 and above. I never seen an equation that actually asks you to integrate. Okay, because now we focus on how you're going to use the list of formulas. Okay, and also if you have that equation, the list of formulas right now, you can also notice that there are also lists of tables. There are also tables with many shape of Fourier series spectrum. So the most important part here is how you're going to use that formula. Maksudnya you tak payah, you don't have to memorize this formula, but you need to understand how you obtain this formula. Okay. Alright, this one you need to actually understand. Okay, understand, because finally you need to write the equation in terms of this Vt. Okay. Kenapa dengan Alif Yusof Rashid left the meeting? Okay. Using Euler's relation, we can express Fourier series in complex exponential form. Okay, remember when you write in terms of this, you actually write the equation in terms of Fourier series trigonometry. But you can also represent the Fourier series in trigonometry form into complex form, because for trigonometries, okay, sorry, I go again here. For trigonometries here, you can only plot single-sided spectrum. Okay, single-sided spectrum. If you want to plot double-sided spectrum, then you need to represent the Fourier series in terms of complex exponential form. So recall the original form here, okay, and then cosine and sine function here is represented. How to represent this? You use the Euler theorem. Okay, so this is based on the Euler theorem. This formula, these two formula, based on Euler's theorem. If in your notes there is a mistake in terms of positive, negative, please fix that. I think in your notes you this is positive, so please fix that. Okay. So for cosine, it plus. For sine is negative, and then divide by 2j. Okay, you replace these equations into original form. Okay, so here, we know that an is cos n omega naught t. So you put this equation, okay, in this cos n omega naught t, it becomes like this. Okay, so this is cos n omega naught t. Okay, and this one is sine n omega naught t. Okay, and then you rearrange the equation so that exponent j and omega naught t here you can take out in the bracket. Okay, so you put together an minus jbn. Okay, how we get this minus jbn? Because remember here j is also negative j is also equal to 1 over j. Betul tak? Kalau j ni naik atas, it will become negative j. Okay. So you rearrange the equation, it become an minus jbn divided by 2 for exponent jn omega naught t part. Okay. Another one is a plus jbn divided by 2 for exponent negative jn omega naught t. Okay. So you rearrange back the equation. Yeah. Okay. So basically, okay, this refer to C naught part. Okay, this one refer to C n part, and this one refer to C negative n part. Okay. Boleh check tak if there is any mistake here in terms of positive, negative? I think it's correct. One is en, yang ni naik atas minus jbn. Okay, correct. And this one naik atas become negative, negative, negative become positive. Okay. Can understand from here to here? Can you understand? Any feedback? Can you understand? Anyone? Okay, thank you. I'm Munira. Okay, now VT here has been simplified to this. Okay, has been simplified to this is equal to C naught plus summation of n equal to 1 to infinity Cn part, okay, which is exponent j n omega naught t part, positive of the phase, and then C negative n, which is the negative of the phase. Okay, basically here Cn is complex conjugate of C negative n. So if you don't understand what is conjugate, you need to recall back your memory. Okay, so conjugate is the opposite of Cn. Okay, it can be opposite in terms of amplitude and also phase. Okay, so hence complex Fourier series can be represented by, so last kali, we can further simplify into shorter equation, which is n from negative infinity to infinity C n exponent j n omega naught t. Okay, so see how you can shorten from the very long equation at Fourier series trigonometry form. Okay, yang tadi yang panjang tu where we have sine and also cosine function. You shorten up until this equation, which is very short. Okay, because this equation already covered from negative n, okay, which is from negative infinity to infinity, where Cn here can be also obtained by integration from 0 to t vt exponent j n omega naught t dt divided by t. So imagine if you have to integrate the very long vt equation just now. It's very, very long, right? Okay. So normally we don't ask you to integrate. Okay. We ask you to use the equation. To use the apa nama tu dekat dalam table tu formulas from the table. Okay, so we have now effect of Fourier series characteristic. You can further simplify lagi. Okay, based on the characteristic of Fourier series. Okay, so we look at the point here. A naught is merely the time average of Vt. So it is 0 if it is symmetry in the period of time t. Okay, so it means that A naught here is 0. Okay, if the signal is symmetry in the period of time t. Okay, so number 2 here, Bn is equal to 0 if Vt has cosine-like even symmetry along the time axis about t equal to 0. Means that V has same value at t and negative t. Okay, if the signal here has cosine-like even symmetry, maksudnya dibentuk the shape is like cosine, okay, where it has even symmetry. The Bn part will become 0. Okay, if the signal has sine-like odd symmetry, okay, odd symmetry, kalau you remember, this is odd symmetry, okay, where you have a same magnitude but at opposite sign, so An part will become 0. Okay, if it only has sine odd symmetry. Kalau cosine, even symmetry, something like this. Okay, An equal to Bn equal to 0 for all even values of n except A naught if Vt has a skew symmetry. So recall back your memory on skew symmetry, or successive half periods have mirror image shapes. Okay, so this is just the point that you can see from the effect of Fourier series characteristic. Okay, so to further simplify based on this point, okay, this is the equation. These are the equations. For example, if Vt is an even symmetry in the period of time t, the equation for Fourier coefficient can be simplified and become, so it means that Bn part equal to 0, so An is like this. Okay, so if Vt is an odd symmetry, okay, means that it looks like cosine shape. Okay, you can further simplify the equation of Fourier series trigonometry to become like this. Okay, so any question before we proceed to examples? Ada question tak? Any question I need to know? Okay, can proceed. So I hope Amirul Irfan is talking on behalf of all of you.
Maybe question after example with them.
Okay. Alright, for example. So I just put one example here because I thought akan jadi lama lagi. Okay, but it's okay. This is example 4. So let me find first example 4. Okay. So given a signal ypt is equal to 2 plus 5 sine 10t minus 40 degrees plus 2 cos 20t plus sine 20t. First, represent the signal in the form of trigonometric Fourier series and then sketch the frequency spectrum. Okay, so for the first question here, you need to plot in terms of single-sided. Why? Because you have to represent the signal in the form of trigonometric Fourier series. Okay, means that it needs to have this cosine and sine component. Okay, and then based on the equation, you can take the amplitude and also phase to plot in terms of single-sided. Okay, and number 2, you represent the signal in the form of complex exponential Fourier series. Okay, so the keyword here is complex, means that you need to change in terms of exponent function. Okay, and sketch the frequency spectrum. Okay, means that magnitude and phase. Normally the question will not put magnitude and phase here. When it say frequency spectrum, then automatically you know consists of both magnitude and also phase. Okay, so for now, this is double-sided. Okay, so once you read the question, understand the question first, and then you can proceed to plot. Okay, remember for final exam normally the question will be very long, but don't panic. Question very long tu just nak bagi mukadimah, just like to make you panic, I don't know. Okay. Okay, first yt equal to okay, yt equal to 2 5 cos 10t minus 40 degrees. Cos ke sine tadi?
Sine, madam.
Okay, sine. So because this is sine, you can change to cos. You straight away add minus 90 degrees. Why? Because you look at the trigonometric series, you want to change sine to cos. Okay, you minus pi over 2. So pi over 2 is 90 degrees. Okay, and then plus 2 cos 20t plus sine 20t. Okay, so if you look at this, these have the same omega. Okay, so from here you can use the equation n from n equal to 1 infinity an cos n omega naught t plus theta n. Okay, so you will get an equal to the square root of an squared plus bn squared. So for this equation, an here is cos component, bn here is sine component. So an is 2, bn is 1. Okay, so 2 squared plus 1 squared square root, you will get 2.24. And then for theta n, you can get this using this equation, arc tangent. So please learn how to use your calculator to find this value. And then arc tangent negative 1 over 2, you get negative 26.57 degrees. Okay, so it doesn't matter if you want to put the phase here in terms of degrees or in terms of pi. Okay, both are accepted. Okay, and sorry, this is yp. So here ypt will become 2 plus 5 cos 10t minus 130 degrees plus 2.24 cos 20t minus 26.57 degrees. Okay, from here straight away you can take the amplitude to plot the frequency spectrum in terms of magnitude first. So omega, you have omega equal to 0, and then you have equal to 10t equal to 20t. So this is omega. Okay, this is ypt. We have at 0 you have 2, and then at you can put arrow like this. At 10t you have a value 5. Okay, and then at 20t we have 2.24. Okay, and then you take the phase part. Okay, we have all the negative part. So here is omega 0, 10t, 20t. You can put like this. For 10t, the value is here. Okay, this is just like plotting. Okay, sketch. Okay, so you don't have to be very precise in terms of the degrees here ataupun the scale here. This one is negative 26.57 degrees. Okay, so any question? Any question? Any question? Okay, so this one is for A. So you answered already. Representation of Fourier series trigonometries. Okay, and also plotting. So this is your answer actually, this one. Okay, this one is trigonometry because it has cos part, cosine part. Okay, the next one we represent in terms of complex coefficient. Okay, so write back the equation that you obtain from the trigonometry form, which is cos 10t minus 130 degrees plus 2.24 cos 20t minus 26.56 degrees. Okay, from here you use Euler's theorem. Okay, so remember Euler's theorem? Like I said, you need to memorize this. Okay, so that it's easier for you to perform all the Fourier series calculation. So here is equal to 2 plus 5 over 2, okay, exponent j 10t minus 130 degrees plus exponent negative j part 10t minus 130 degrees. So that's why I said this is quite long. So this is only for one component, for 5 cos ni. Okay, and then another part is 2.24 divided by 2 exponent j 20t minus 26.56 degrees plus exponent negative j 20t minus 26.56 degrees. So I hope you can understand my apa nama handwriting. Okay, and then you solve for this. Okay, you will get 2 plus 2.5 exponent negative j 130 degrees. You put like this. Exponent j 10t. Why you put like this? Because you want to take out the frequency part. Okay, this is the frequency part, j 10t. J negative 130 degrees is phase part. Okay, phase shift part. Okay, plus 2.5 e j 130 degrees. This one negative become positive. Okay, exponent negative j 10t plus 1.12 exponent negative j 26.56 degrees. Okay, you put in the bracket here exponent j 20t plus 1.12 exponent j 26.56 degrees exponent negative j 20t. Okay, so you actually can rearrange so that you put you write from the lowest frequency, which is negative j 20 and then negative j 10 and then 10 and 20. Okay, so that it's easy for you to plot. Tapi because of the space, I will not rewrite this. Okay, but why you need to take out the frequency? Because you want to plot. Okay, it's easy for you to plot. So now you plot both frequency and also you plot frequency spectrum in terms of both magnitude and also phase. First, magnitude, because this is double-sided, so it involves both part, negative and positive, okay, of omega. So we have omega from 10t, 20t, 0, negative, 10t, negative 20t. Okay, 0, for 0 omega, the magnitude here is 2. For 10t here, the magnitude here is 2.5. And for 20t is 1.2. Okay, this one 2.5, 1.12. Okay, this one is, if you want to say magnitude, okay, you need to put something like this one. Okay, maksudnya you put positive side only. Let's say there is a negative. Maybe here is negative 1.12, but you want to plot positive, you put the magnitude sign here. If you don't want to plot the magnitude, you just put YT here, then you can plot it negative. Okay, but you see here, it is symmetry. Okay, if you plot only on the positive side, It is symmetry, right? Okay, should be like this one 1.12, this side also 1.12. Okay, and then for the face become like this. Sorry, should be in the middle here. Okay, so be like this. Here is 0. Okay, can put like this. This is the face. Okay, and then at negative t, negative 10t, we have 130 degrees. At negative 20t, we have 26.56 degrees. Okay, this is negative 10t, this is negative 20t. Okay, at 10t, we have negative 130 degrees. This is what it means by complex conjugate. Okay, the phase will be different. And this one we have this one is 10t, 20t, when we have negative 26.56 degrees. Okay, so this is your answer. Any question? Any question? May I know if you have any question? Can you give feedback to me if you have any question?
No, doctor. Thanks.
Okay. How about others? Do you have any question? Okay. So I hope all of you can understand this simple example. Okay. Sekejap. Let me stop sharing first. Sharing. Okay. I hope you tak tidur Okay. So I'm also going to show you the formula on signal, the list of formula that I'm talking about. So let me share you first my another window. Okay. If you can see here, this is the list of formulas. Okay, this is the list of formulas. We have integration formulas, differentiation formulas. So please print one copy for you. Okay, it has the formulas from the first, not from the first chapter, the second chapter up until the sixth chapter. Okay, with trigonometry identities. Okay, you will use this a lot. You will use this a lot. The trigonometry identities. This is the Euler theorem. Okay. And then moving on, we will start the equations start with the Fourier series. For international student, if you don't understand anything, you can ask me. I will try again to find the English version for this. Okay. But not so much. I think that some of these formulas have meaning in English. Okay, so this is the Fourier coefficient, like I said before, the properties. Okay, so no need to memorize, but need to know how to use this. Okay, this is for the complex component. And okay, this is the table of Fourier coefficient for different types of waveform. Okay, this waveform has Q symmetry, ada yang okay, so normally the question will ask you to find the Fourier coefficient for this type of waveform. Okay, so I don't want to show you the examples now. Okay, I will make another video for these examples, the tutorial session. Okay, so basically when the question asks you to write the Fourier coefficient, it will be based on this waveform, square wave, sawtooth, betul You just need to know how to utilize the equation here, Cn ataupun Cn equal to 0. Okay, so that I will show you in another video. Boleh tak? Okay, I'm not going to show you today because I think it will be too much for today. Then for another page dah masuk Fourier transform. Okay, and also another one here is notes and on complex number. Complex number and phase form. I think I compile this from various apa nama sources. Okay, so you need to recall back the memory Like I said before, when you see j, you actually can change it into exponent j pi over 2. Okay, or exponent j 3 pi over 2. Okay, because the phase can repeat itself kan. And then exponent j pi is also equivalent to -1 and vice versa. Okay, and recall back your memory on the polar and rectangular number. So you can see the examples. What is complex conjugate? Okay. Okay, how to change from phasor to rectangular number. So this is all very important. Nanti kita akan guna banyak. So please take your time to recall back your memory. We're also going to use this on Fourier transform and also Laplace transform. Okay. There's another graph here, but I didn't put it here. Okay, in terms of complex exponential punya graph. Alright, so any other question?
Adam,
Ya? Tak ada ke ada?
tak ada.
Okay.